Okay, in this video we're going to talk about ratios and proportions. We're actually going to start off with looking at proportions and then come back to ratios because when it comes to the problems that we're going to see on the GED test involving ratios, we actually use proportions to solve them. So I want to talk about proportions first. Okay, so what is a proportion? A proportion is basically just two fractions that are set equal to each other. And those fractions are equivalent fractions. So we can, I know we've already talked about equivalent fractions. We could think about if we're doing an addition problem with 1/2 and we needed a denominator of 6. What would I do to 2 to get to 6? I would multiply it by 3. So we know I do the same thing to the numerator here. Okay, and this would be 3. But we can also think about it in the way that we see proportions written. Instead of sort of like an empty numerator here, we're thinking what goes here, right? We're going to put an x. So this is sort of our introduction into algebra, right? We're now using a letter, the letter x, we should call it a variable, to represent the value that we don't know, right? Think about it like an empty box, okay? Sometimes we could just look at the proportion and it sort of screams at us, right? Because I'm like, oh, 2 times 3 is 6. So I'm going to do 1 times 3 and get 3 here. But the numbers don't always work out so nicely, so we want to have a different tried and true method that we can always do, and that's called cross multiplication. So what does cross multiplication look like? Well, just like it sounds, we're going to multiply our diagonals. Okay, so 1 times 6 gives me 6, and 2 times x will give me 2x, and then we set them equal to each other. Okay, so we just multiplied our diagonals and put them equal to one another. Let's just take a look at 2x for a second, okay? In the term 2x, x is the variable, 2 is what we call the coefficient. Coefficient. So in the term 2x, x is the variable, 2 is the coefficient of x. So our first step here of cross multiplying, we do 2 times x, 1 times 6, and then we divide both sides of the equal sign by the coefficient of x. So the coefficient here is 2. I'm going to divide by 2. Now I could show it like this, right? Divided by 2, but remember a fraction bar also means division. So we can show it like this, divided by 2, divided by 2. I'll put the equal sign down. Well, 2 divided by 2 is just 1. So we have 1x, and when we just have 1x, we don't have to write the coefficient, we just put x. Okay, and then 6 divided by 2 gives me 3. Okay, so here we're going to take a look at one more proportion and just focus on the process for solving it. So again, the first step is to cross multiply. So multiply my diagonals. It doesn't really matter which set of diagonals I multiply first, okay? But we're going to set both of our answers equal to one another. Let's start with 5 times 13. Well, 5 times 10 is 50. 5 times 3 is 15. So together that makes 65. And then 2 times x is just 2x, okay? So that right there, that was step 1, cross multiply. This here was step number 1. Now we're going to divide by the coefficient of x. What's the coefficient of x here? 2. So we're going to divide both sides by 2. Okay, and a lot of times, on a problem like this, it'll be on the calculator section, but even if we don't have a calculator, we can do that as well. 2 divided by 2 gives me 1, so these essentially cancel out, leaving us just with x. And then 65 divided by 2 would give me 32.5. Again, we could do that out on the calculator, or we've talked about how we could do this here. 2 goes into 6 3 times. There's nothing left over. Bring down the 5. 2 goes into 5 2 times, which is 4, leaving me 1 left over. Okay, I need another number to bring down, another digit, so I add my decimal point. I have zeros here if I need. Bring down the 0. 2 goes into 10. 5 times, and I'm running out of space, but there'll be nothing left over, right? 32.5. So I know we just focused on the process. What we're going to look at now is an example of a couple situational problems, word problems that you might see, and how we can use proportions to solve them. Okay, so we're going to take a look at an example of a word problem that we can solve using proportions. So it says, it takes you 4 hours to mow 5 lawns. How many lawns can you mow in 10 hours? So we need to sort of set our proportion up here, and there's a couple different ways we could do it, but we know it's going to be 2 fractions that are set equal to each other. So we could say, well, let's put, right, the 4 hours and the 5 lawns go together, right, because it takes 4 hours to do 5 lawns. So I could say, well, 4 hours for 5 lawns, and the way that I set up this fraction is basically going to tell me how to set up this, right? Because what we've set up here is hours over lawns. So over here, the hours needs to go up in the numerator, and the lawns needs to go down in the denominator. Which of these two do I know? I know hours, 10. So 10 goes here, and then the value which I don't know, which is how many lawns can I mow in that 10 hours, I'll put X. Okay, but let's set it up a different way. We could obviously flip it. I could put 5 lawns in the numerator and 4 hours in the denominator. That doesn't make a difference to me in terms of my answer. It just makes a difference in terms of how I set up this other fraction, right? Because now instead of hours over lawns, I've made it lawns over hours. So where should this 10 hours go in this situation? It should go in the denominator. Okay, and then X up here. But notice that for both of these, when we cross multiply, 4 times X, 4 times X, 5 times 10, 5 times 10, right? Our cross multiplication will be exactly the same. Let's actually set it up one other way that would also work. We could do hours over hours and lawns over lawns. We just need to make sure that like hours from the first example and lawns from the first example, those both go in the numerator, and then hours from the second example, lawns from the second example would go in the denominator. So what would it look like there? Well, do I know how many hours it took in the first example? Yes, it took 4 hours. Do I know how many hours it took in the second example? Yes, 10 hours. Okay, do I know how many lawns I could mow in that first example? 5 lawns. And then what about in the second example? No, I don't, right? That's the thing we're trying to find. So that's X. Okay, again, notice 4 times X, 5 times 10. My cross multiplication is the same in all 3 of these setups. So let's do the cross multiplication. 4 times X, 4X gives me 5 times 10, which is 50. Okay, step 2, divide by the coefficient of X. So we're going to divide both sides by 4. Okay, and then again, we could use a calculator, but we could even think about it in our head. I'm going to count up my 4 times tables as far as I can get with 50. Biggest one that I can think of close to 50 is 48, right, which is 12 times, leaving me 2 left over, and 2/4 is 1/2, or 0.5. So this is 12.5. Okay, so we could mow 12.5 lawns in 10 hours. We're going to take a look at a couple other examples, and we won't do them out quite to this extent with all these different variations. Okay, so let's take a look at another example of a word problem we could solve with proportions. So if you earn $3,100 in a month, how much will you make in a year? So we could set up our proportion. We're going to set it up like money over months equals money over months. Okay, so what's our first situation? Well, in 1 month, how much did we earn? 3,100. Okay, and then we want to know how much we're going to make in a year. we need these units to be the same. So we have to turn the year into months. How many months is in a year? 12 months. So 12. And then do we know how much money we're going to make in the year? No, that's the thing we're trying to find out. So it will be X dollars, right? We don't know how many. Okay? So that's kind of the hard part, right? Make sure we set up the proportion properly. Once we've done that, follow these two steps. We need to cross multiply. Well, 1 times X just gives me X. So that's nice. And then 3,100 times 12. Again, we could use a calculator, but let's review our multiplication. 2 times 0 is 0, 0, 2, 6. I'm now multiplying by 10, so I'm adding the 0 here first. 0, 0, 1, 3. Let's add up our partial products. So you would make $37,200 in a year, right, at that rate. Okay, so we're going to take a look at one more word problem involving proportions. So it takes a train 72 minutes to travel the 90 miles from Philadelphia to New York City. At that same rate of speed, how long will the 300-mile trip from New York City to Boston take? So let's think about how we could set up our proportion. I think the most logical way to do it would be minutes over miles and minutes over miles, or miles over minutes, miles over minutes. It doesn't really matter if we flip-flop them, but let's think about okay, let's do all the info from the Philly to NYC train ride on one side, and then the NYC to Boston train ride on the other. It doesn't matter if I put minutes on top and miles on the bottom, or miles on top. So let's pick one. Let's put the 72 minutes on the top, right? The 72 minutes pairs with the 90 miles, so that will go in the denominator. Okay, and then over here, what do I know about the New York City to Boston trip? Do I know the minutes or the miles? I know the miles. Where should the miles go? In the denominator, because the miles was in the denominator here. So 300 miles, and then this is what we don't know, so X. All right, we cross multiply. 90X equals, again, let's just do it out for practice. You'll probably have a calculator to use. 0, 0, 6, placeholder 0, 0, 0, 21. So 90x equals 21,600. Okay, what's step 2? Divide by the coefficient. Again, just because the numbers get more complicated, the process doesn't change. And I'll say it one more time, you'll probably have a calculator if they give you a problem like this. But even if they don't, we're going to use this as an opportunity to review some of our basic operations. So this will get me x, right? And then let's do out some long division. 21,600 divided by 90. Okay, can 90 go into 21? Nope. 216? It can. It can go in 2 times, right? Remember, if I know my 9 times tables, I also know my 90 times tables. 2 times 9 is 18, so 2 times 90 is 180. Okay, so we get 36 left over. Bring down the next digit, 360. Well, 36 is a 9 times table, right? 9 times 4, so 90 times 4 is 360. This goes in 4 times. Now we have nothing left over. Bring down one more 0. It goes in 0 times, so we get 240. 240 what? Minutes, right? You got to remember the context of the problem. So it would take 240 minutes to go from New York City to Boston. If we wanted to know, well, how many hours is that? Well, it's 60 minutes per hour, so we divide by 60, right? This is 4 hours, 4-hour trip. Okay, so now let's take a look at ratios and what ratios are. So let's imagine we have a room with 15 people, 10 women and 5 men. So we could talk about the ratio of women to men. Okay, this symbol is a symbol that we use, the colon here, for a ratio. So say, what's the ratio of women to men? Well, there are 10 women and 5 men. So there's a 10 to 5 ratio. But we always want to simplify our ratios down, right? So we look just like fractions. We can simplify fractions. We simplify ratios. Is there a common factor here? Yes, these are both 5 times tables. So we can, just like with fractions, we can simplify fractions. We can simplify ratios. This comes down to a ratio of 2 to 1, right? There are 2 women for every 1 man in that room. Okay, but what's the thing that disappears when we write a ratio from this situation? The thing that disappears is the 15 people, right? The total number of people. So if we were told that there's a 10 to 5 ratio, right? Or what does that mean? There's 15 people. What fraction of the people are women? Well, 10/15 of the people are women, and 5/15 of the people are men, right? Together, that accounts for all 15 of the 15 people. Okay? So even here, right, if I was told a 2 to 1 ratio, I said, well, what fraction of the room is women? There's 2 women out of a total of how many people in this scenario, in this ratio? The total is 3, right? So 2/3 of the people are women and 1/3 of the people are men. Okay, it's important when we're thinking about ratios that we can look at something like this and connect it to the total. So another common example where we see ratios is in student-teacher ratios, like in schools, right? A school might talk about, oh, here's our student-teacher ratio. So if there's a school with 120 students and 6 teachers, what's the student-teacher ratio? Well, there's 120 students for every 6 teachers. Can we simplify this, right? Well, 12 is a 6 times table, so 120 must be a 6 times table. 6 goes into 12 2 times, so it goes into 120 20 times. So I can divide these both by 6, and we get a 20 to 1 student to teacher ratio. So now we're going to look at a couple word problems and see how we use proportions as a tool to help us in ratio problems as well. Okay, so let's imagine you're on a construction site and you're told to mix some paint. Okay, you want to get a certain color, and you need to mix the red and the blue paint at a ratio of 3 to 5. So 3 parts red for every 5 parts blue. So if you're told that you need 64 gallons of this mixed paint color, how many gallons would you need of each color, right? If you were to go to the store, how many gallons do you need to buy of each? So the hard part here is that the ratio is comparing for us the red paint to the blue paint, but it's sort of hiding from us the total, right? They didn't tell me how much like red paint I'm gonna need or how much blue paint I need. They just told me what's the total amount of paint that I need. So we need to think about this ratio relative to the whole, right? Let's actually think, like, kind of convert these to fractions. So if I take 3 parts red paint and 5 parts blue paint and put them together, how many parts of paint, or we can even think about it as gallons, right? 3 gallons of red and 5 gallons of blue. Together that's 8, that'll make 8 gallons of mixed paint, right? So I could say, well, what's the ratio of red paint to total, right? Or I could just express these as fractions with the denominator of 8. So this is 3/8 and this is 5/8 of my total paint, right? The blue needs to be 5/8, the red needs to be 3/8. So let's use this to help us now, okay? If we have 3 gallons of red paint for 8 gallons of mixed paint. Well, what can I set up over here on my other side of my proportion? I don't know the total amount of red paint that I need, but I do know my total amount of mixed paint, right? 64 gallons of mixed paint. And then what can I put here? X. So notice how we transformed this ratio problem into a proportion. And now we can follow these 2 steps to solve our proportion. Let's cross multiply. 8 times x is 8x. 3 times 64. Well, 3 times 60 is 180. 3 times 4 is 12, so 192. And then what's step number 2? Divide by the coefficient of x. Divide by 8. Divide by 8. Okay, this gives me x. Let's just jump. Let's show this on a number line. Let's just jump up by 8s. Skip counting to get to 192. Well, what's the big first jump I can make? 8 times 20. Because I know 8 times 2 is 16. 8 times 20, 160. From there, how many more am I missing? I'm missing 32 more, which is 8 times 4. So 24 total. So x is equal to 24. And what did x represent? The amount of red paint that I will need. So if I need 24 gallons of red, how many gallons of blue? Well, it's 64 total, so I could just take away, right? I need 40 gallons of blue paint. Okay, so ratios and proportions, as I hope you can see, very closely connected. But the thing that you have to watch out for with ratios is they don't tell you the total, right? In order to figure out the total, we need to add up the 2 parts of our ratio. So I hope that this video has been helpful. Thanks again, as always, for watching, and I'll see you in the next one.